Hello. We're going to start talking or discuss the differences between three different concepts that you'll hear over and over again in statics or in physics in general. So one is we're going to do is we're going to see mass. Okay? And we're also going to see force and what usually comes up and some confusion between a mass and a force is weight. So let's start with mass. So mass is just a body with some volume and some density. It could be a book, it could be a telephone, it could be the Earth. The Earth has some sort of mass. The sun, down to the electron, has some sort of mass. But that's all it is. It doesn't rely on a force. It has no vector. It is just a component. In the SI system, we have a measurement, and that's in kilograms of the unit. In the British system, there's a couple, but mostly it's going to be a pound mass. The point here, it's not a vector, it's not a force, it's not a weight, it's a mass. Like I said, everything out of in physical concept has a mass. A force, or let's go with weight now. A weight needs some sort of mass to start with, but it has to undergo some sort of gravitational field. So let's put that. And usually, in most cases, it is down the paper. And it is acting on all sides. Sometimes you'll even see that with the center of gravity somewhere and a big vector here. So this is weight. And to get the weight, as you've seen in most physics classes, it's your mass, right here, your m, times the gravity. Now the gravity on planet Earth is 9.81 meters per second squared. It's an acceleration, and it's also equal to 32.17 feet per second squared in the British system. So again, weight is actually a vector. That's important, all right? And it has units. So if we said the units of Newton or pound force, all right? So those are the difference between a mass and a weight. So let's move on to a force. Now a force, so let's change this. A force can be a weight, not necessarily. So I could apply a force, or one could apply a force with a hammer, or some sort of pushing or pulling on something. So it's a push or pull. For right now, it's a little different than that, but push or pull. And I'm applying a force over some body. So if I apply a force here, the applied force, this is also measured in newtons or pound force. Nothing to do with really weight, but although a weight is a force, but a force isn't necessarily always a weight. And a force does have magnitude and direction, just like the weight. Most of the time in statics, you'll see in a standard x, y coordinate system, you'll see weight going in the y direction. Now we also have a standard in 3 dimensions. We have x, we have y, and we have z, and it's most of the time going in the negative z direction is the weight. But a force can be applied anywhere. I can apply a force up, I can apply a force at an angle, I can apply a force this way, all different forces acting on some body. But to note, they are different. A force and weight are not necessarily the same. A weight can be treated as a force, but a force isn't necessarily a weight. A weight does have mass, but a mass does not have weight. Again, to recap, mass is made up of all things matter. You can be floating in space and have no weight, but you have mass. Weight constitutes some gravitational force, or gravitational acceleration on or exerting on the mass itself. So that's a weight. Now, a force is a push or pull in the static sense. They're very similar, and it's make sure you understand the differences. I constantly get students saying, if I tell them a force, they give me the units in terms of kilogram or pound mass. This is incorrect. When a problem is asked for a force or weight, it's in newtons or pound force or something like that, and always given in some direction as well. A mass is just some matter pushed up or some matter densed in some sort of volume. Hope this helps clarifying the mass, force, and weight. I will see you later.